Hello and welcome to another episode of Adventures in .NET. I'm Shawn Clabough, and with me today is Caleb Wells with the Typhon Group. Want to say hi, Caleb?
Hey, y'all. How y'all doing?
All right. And our guest today is Colby Tresness. He's with Microsoft. He's a project manager on Azure Functions. Is that right, Colby?
Yeah. So I'm it's actually kind of complicated. My title is program manager. I would consider myself more of a product manager, but I do end up doing some project management. So it's let's just call me a generic PM.
You manage all the way around.
Yeah. Lots of different stuff.
Yeah. Can you tell us a little bit about Azure Functions for people who aren't familiar with them?
Yeah, absolutely. So Azure Functions is a product that Microsoft provides, and I think it's actually two different things that I want to go through. The first is a programming model. So it is a way of writing code that is what we refer to as functions as a service. So the idea is you write kind of a small bit of code, one function that has some trigger and maybe some connections to other services. We call those bindings. I can get into that a little later. The core idea is you've got this little bit of code that can react to events. So that's one piece of functions. It's this functions as a service programming model. It's that you're writing this small bit of code reacting to events. Now, the other piece is this serverless scale. So serverless is kind of a buzzword that's being thrown around a lot lately. But the really core definition is just whatever application load your functions, in this case, are seeing, our infrastructure will kind of scale dynamically to handle that load. So what that means is that you don't have to worry about provisioning new servers. You don't have to worry about really anything with your application other than the actual business logic of the code that you're writing. So that's, I think, a pretty decent introduction. The two pieces are this functions as a service and this serverless scale. You can have one without the other, for instance. We do have actually in Azure Functions, there are other ways of running your functions, so you don't actually have to have the serverless scale, but we find that most people like that behavior.
So what would be the closest comparable structure to functions as a service, right? Because you have IaaS, and you have PaaS, you have SaaS.
So the way I think about it is this kind of transition of how people have been developing applications over the course of time. I mean, before the cloud, of course, everything was on-prem. With the advent of the cloud, the initial promise was, you won't have to worry about really anything. All of the infrastructure will be handled for you. But what we got was actually the physical infrastructure turned into logical infrastructure. And there were still a lot of things that you as the developer had to worry about. Then, of course, came around PaaS, which is platform as a service, where you, the developer, don't have to worry about a lot of the underlying infrastructure things. We have a service in Azure, App Service, that handles a lot of these things really well for you. A good example of the benefit of this is the Spectre and Meltdown vulnerability from a while ago. The Azure App Service at the time automatically updated, I think it was somewhere between 600,000 and 1 million virtual machines without any of their customers knowing that we had patched that vulnerability for you. So things like security updates, improvements to the actual hardware, things like that are things that we abstract for you with platform as a service. But with platform as a service, you still have to manage your scale. So I would put serverless and kind of functions as a service as one step more abstraction away from platform as a service. It's kind of one more step in the direction of not worrying about things. Ultimately, there's this trade-off between productivity and control. And functions are kind of the tip of productivity while you're still writing code. There are other services like software as a service and things like Logic Apps, things like Microsoft Flow, other services that kind of let you do sort of similar things without actually writing code. But while you're still writing code, I think this is the very tip of focusing on what your application actually needs to do and not about the infrastructure that it's running on.
Okay.
So my question is more about what's the use case for Azure Functions? When would I want to write something in Azure Functions versus just putting an API in my existing application?
I typically answer this in one of two ways. I think that functions are really good for greenfield applications. So anything that's new, I think it's really easy to get started with functions. It's very easy to figure out whether this is the solution for you, if that makes sense, because it's just so easy to get started because there's not a lot of overhead. So if you're building a new application, I think that's a really good place to start, and then fail fast and see if you need something that has a little more control, a little more knobs, things that you can mess with. The other thing I would say is that kind of extending existing applications is really pretty good with functions, because you don't actually have to touch any of the existing applications. So I like to take, for example, the web API workload, which is something that we see a lot on functions. if you're building a new web API, you could start from scratch with, whatever server, ASP.NET application that you'd like, or you could just build the one function, the one kind of piece of logic you actually need, and then have this kind of suite of maybe microservices. Alternatively, if you have an existing web API that you don't want to touch, but maybe you need to update some additional route, maybe you need to add something like a new capability in your website that you want to be able to have an API for, but maybe your application was built a while ago and you don't want to go touch your legacy code. Functions is a really good way to do that while maintaining that existing infrastructure. When I would suggest people to use functions is when they're either building something new or doing something that is an extension to an existing application. Of course, you can completely re-architect your existing solution with serverless if you'd like, with functions as a service, but that is a pretty big undertaking. So it's not something that I would suggest unless you actually are like really bought in and decided that you need to rewrite it anyways. That kind of covers the situations in which you would. That's not exactly the types of workloads, so maybe that would help a little bit as well. We see a lot of people doing web workloads, like I said, but I would say that really the best fit for serverless and functions is anything that is based on events, anything that is any type of scale that is variable at all. So things like data processing, maybe you have some little bit of logic you need to do to transform data coming from source A to go to source B. Maybe you have, various IoT devices that are sending messages up to the cloud and you need to do some sort of analysis on that data. Anything that has events like that, variable load, that's when functions is really, really strong.
Okay. The company I work for, we're actually just starting the process of rebuilding our application from scratch. Mm-hmm. Software as a service for nursing schools, but it's currently massive. And while we're going to consolidate code and try to, write a lot of it in to be reusable using .NET Core and C#, I'm curious from a function standpoint, how would I go about, and we don't have to get into the nitty gritty, but how would I go about writing Web API 2 using C# and functions? How does that work locally in Visual Studio or VS Code? How do you go about that?
Cool. So I think I'll answer for web APIs in general. The basic idea is that you're going to want to actually figure out how your application will have to kind of break down into its, constituent components. So the thing about serverless is that you are kind of re-architecting your application slightly. You can't take the exact same paradigm, with your typical client-server application and then immediately put it into serverless. The architecture you have to think about is much more based on where the events are flowing and kind of what the individual pieces actually need to do. So what I would say here is that, first of all, were I approaching a problem where I need to kind of take an existing web API and kind of rebuild it with a new situation, I would figure out what the actual units of work that I'm trying to do, what the the core objects, the primaries. These core objects then would kind of be split out into individual function apps. So that's one thing I haven't explained yet. We have this nice level of abstraction called a function app, which is the logical grouping around a set of functions. These functions scale together, they're deployed together, they're managed together. So what would happen is I would say maybe I've got this one section of my new web API that I want to build. Maybe it's everything to deal with this one entity, like, everything to do with my user API or something. Mm-hmm. I would maybe group all of these together since they're things that probably need to be called in a similar fashion. Maybe they chain, maybe they do any number of things. I would probably group these together. I would go into Visual Studio or VS Code, and then I would actually create a new function app. What that is again, this container for your functions. And then once I have that function app, which is my logical grouping, I'll go ahead and create individual HTTP-based functions for each of these actual API endpoints that I want.
Okay. So in that sense, same thing as Web API 2 in a MVC app is you're breaking them up into get, puts, post, deletes, and putting them together in similar to a controller, right? Things that flow together. Okay.
Yeah, I think that's a good way to describe it. You'll have to tweak some of the config of each of the functions to actually specify which ones are get, post, which ones are whatever thing. But I guess a good segue into explaining the whole triggers bindings thing is really briefly, every function must have one trigger. We need to know when to actually start that piece of code. Okay. So example of a trigger is HTTP. That's kind of the simplest one that everyone gets started with, but there are also some other ones that make a lot of sense for the data processing scenarios I was talking about. Things like Azure Event Hubs, things like Azure Storage. If you drop something in Azure Storage, you can even do things like IoT Hub, things like that. So we have a lot of different event triggers. And then there's this notion of an input binding and an output binding. So the idea here is that in addition to starting off your function, what the input binding will do is say, if you need to go and fetch a resource from another part of Azure, it'll go and do the negotiation for you, essentially. So instead of having to take that boilerplate code that you would call every time to use whatever SDK to actually go and grab that piece of information from table storage, we can go and actually populate your function with that information for you. And then the output binding is just wherever you want this data to go at the end of the function. So for an HTTP request, it would make sense to give an HTTP response as your output for that.
Right. For triggers, how exactly does that work? Are the functions always on and always available? Because I understand you're only charged for when the functions are being used, right? When there's the resource being.
So when we're talking about the serverless functions, the reason I have to be careful with my language here is that we do, as I briefly said, we do support multiple different plans. So if you're running functions in the consumption plan, which is the serverless option, that's where that pricing applies. You can also run functions in kind of an always-on manner in the dedicated plan. The reason I wanted to do that introduction at the beginning of the difference between serverless and functions as a service is that you can actually run the functions as a service piece without serverless in this app service plan. So it's basically running functions as a service with platform as a service, if that makes sense. So I know all the names are getting a little confusing here, but the core idea is there are two different main ways of running functions. One is serverless, one is not serverless. Let's now talk about the serverless one, because I think that's much more interesting for this context of things being on and off and scaling dynamically.
Right.
So the serverless way of doing things, your functions are not running in general. If you're not getting any usage, your functions are not running. This is how the economics of our service actually makes sense, because otherwise we would just be having provisioned resources for everyone and they're only paying for what they're used. So we actually dynamically allocate and deallocate the resources for customers. We have, of course, a portion of that actually already running. So we kind of have this pool of warm workers is the way to think about it. And this pool of warm workers is then actually specialized to whatever application code is needed at the time. So let's say you're starting your application that hasn't run in, say, 24 hours. What will happen under the hood, this is actually what is referred to as cold start, just for context. What will happen under the hood as we will go grab a warm instance of functions that is running and then specialize it towards your application code. If we see that we need to actually run functions on that specific user's code, it will then go through the process of, JITting, doing all of the process of getting everything warmed up. I won't go through all of the details there. Once everything is fully warm, then your application will go ahead and run on that infrastructure. That entire process takes about 2 seconds-ish is the rough amount of time it generally takes. Subsequent requests, of course, will be considerably faster. So we keep your functions alive after you've executed them for about 20 minutes. And so any subsequent request will go to that instance and will have kind of the benefit of already reaching something that has been turned on already. What that actually does is, because these are actually scaled at the function app level, first request to any function will kind of warm up your infrastructure, and then you'll get a nice amount of requests that can go to that same instance without having to scale out the infrastructure further. As you may have guessed at this point, anytime we actually scale out to a new instance to have more executions, you will see another cold start for that new instance. But the thing is that you already have an instance running, so we can divert some of the traffic to that running instance. So it's not quite as drastic, the slowdown that people will see.
Yeah, good. Because my question was going to be, is that cold start penalty, is that per function or per function group or anything like that? So
we actually do this slightly differently than some of our competitors. The main competitor that we talk about a lot is Aws Lambda. And they have a very different model than we do, in the sense that every function invocation will have a cold start for them because they're spinning up new instances for every single function.
Every call, every trigger. Okay.
Yeah, which is why it's a much bigger deal. Of course, they start it up for every invocation, but of course, once they see invocations coming in, they start to really rapidly spin up, and you really do only see it for that first batch of executions for Lambda. For us, it's slightly different. We do process many invocations on the same instance, but we have to warm up that individual instance. So you'll see fewer cold starts for us. Ours are slightly longer just because of how the infrastructure works, but it is something that you'll see less frequently for
an example in production for software as a service, if we're using serverless functions a good deal, maybe say for reporting, right? Because it's its own, concept, right? And it can be segmented off. We could do something on our end that would trigger a function to spin up, say, 7:30, because we know a lot of our clients are going to be getting in 8:30. And then that way it would already have been started.
Yeah.
No one outside of us would get that 2-second penalty, so to speak. I mean, 2 seconds isn't long, but in context.
Yeah. In context, sometimes it is. If you're doing a reactive website, you don't want something to wait 2 seconds.
So something I was thinking about is, just making some sort of a dummy function that, okay, I know I'm going to be doing a bunch of function calls here in a second or 10 seconds or whatever. I might want to make one function just to get things warmed up so that once they have to call the real functions, those are already warmed up.
Yeah, honestly, that's what we see a lot of people doing that. It's a pretty standard practice. That being said, the thing about cold start is that it's kind of more of a perception issue than an issue that we actually see a ton of customers having. Once you have an application with any load at all, this issue mostly goes away because you're on, like you'll usually get at least one request for a lot of applications. I won't generalize, but for a lot of applications, you get at least one request every 20 minutes anyways. So unless it's a very low traffic application, like a demo application or something, then you'll have a pretty responsive application.
So would you be charged for the 20 minutes or just the time that the function took?
Great question. Just the time your function took.
Okay.
So you are not paying for any of us. That 20 minutes is actually something that we could tweak. We don't promise that at all. That's just the buffer in our system that we find is a good number for when someone, if you haven't executed a function in about 20 minutes, it seems to be pretty unlikely that you will come back for any recognizable period of time. Smaller than that, we find that people do take quick breaks and, maybe execute every 5 minutes or something like that. So that's why we have that kind of built-in timeout. The one other thing I did want to mention here is that I'd be remiss if I didn't talk a little bit here about the Azure Functions Premium plan, which is something that we actually have in preview. Premium plan is so I've talked a lot about these various plans, and I recognize that it's probably a little confusing, but if I have one main message, there is the consumption mode, which is the fully serverless, pay for only what you use, pay zero when you don't use it. There's the dedicated plan, which is my functions are always available. I'm paying for the infrastructure all of the time. And then the premium plan is kind of what we view as the best of both worlds. So the premium plan is you're getting dedicated hardware, as in we reserve one instance for you all the time. So what that means, because you always have one instance available, you will always have a warm instance to go to. So you will never have a cold start, which is really powerful. It is slightly more expensive. It's not called the premium plan for no reason. But you also get, with the premium plan, some more advanced networking features that I know a lot of the enterprise customers are looking for, like point-to-site VPN, kind of just the triggering your function from a VNet is something that we're working on. A lot of these kind of isolated network features that people want for kind of more enterprisey scenarios. So I would just say that if you are someone who is worried about cold start and you are someone who is working at a larger company who or even a smaller company that's willing to put forward a little more money towards the problem as opposed to dealing with it, the premium plan is a really good option. You can configure the number of instances that you'd like to stay warm. So there's a minimum of 1, but you can keep warm up to a maximum of, I think, 20, and then maybe 10. I'm not 100% sure. But you can then kind of have a really good system that's running on actually better hardware even. So the requests and the throughput themselves, and the throughput therein is actually quite a bit better for the premium plan as well. So that's my little spiel on premium. It's It's in public preview right now. We're actively working on developing. So it's something that we're excited about the future of.
Cool. Very cool. Another thing that comes to mind with functions and really with cloud in general, right, is the security of those functions and who has access to them and who doesn't, right? Yeah. We're working through Identity Server right now on how we're going to set up our infrastructure, right? And you have the idea of protected resources and keys. So, you're limited to who you can talk to. How does that work with functions?
Yeah, so there are a couple different features we have here. I think the main one is just it's very easy. We have keys for each function. So it's very easy to lock any function down behind that key.
Okay.
The other thing I want to talk about is this feature we have that's also something that's available in App Service called Easy Auth. I like it quite a bit. It's rather than locking specific functions down behind keys, it's kind of a turnkey auth solution that lets you just basically click a button and say, I would like social auth for my entire application. Basically, you say, you click a button in the Azure portal and it says turn on. The official name is not Easy Auth. I think it's managed identity. It's I think in App Service it's App Service Identity and it might be Function App Identity. I'm not 100% sure. But the core idea is you turn this feature on, and what it does is it puts basically a facade in front of your entire application. Says you have to be logged in with one of these three services. I think it's right now Facebook, Twitter, Google Auth. And then once you're logged in, you'll be able to access that web page. That's a really nice feature that a lot of people get a lot of success around. The other thing I want to talk about, I misspoke and mentioned it earlier, but managed identity is another thing that's really, really cool. Managed identity is a way that you can actually set up the authentication between your function app and other Azure services. So the idea here is that a lot of the way users will do calls to other authenticated services is just by providing keys and API keys in the actual application settings of your function app. Those are, of course, encrypted at rest and fully secure in and of themselves. But of course, it's not necessarily the best situation. So a lot of people will want to have these in Key Vault, for instance. Azure Key Vault is a solution that people will use quite a bit for that. The idea of a managed identity, though, is that rather than actually having this secret that you have to share between your application to get your, say, function app to communicate with your Cosmos DB, the managed identity, once you've configured that, is you're given kind of an identity for your function app itself. So that function app now can, by assigning this identity to the function app and giving it permissions on the Cosmos DB, you don't have to actually worry about managing those secrets yourself. It's kind of a fully managed experience where you can say just the one time, this is allowed to talk to this, essentially, and we behind the scenes will kind of manage that connection for you. So yeah, I think that was just a brief overview into a lot of the different authentication features we have. The bottom line is it's not too hard to actually put some thought into this and secure your applications when you're building with functions.
Okay, good to know. The next thing I'm curious about is, so obviously Azure Functions, well, I'm assuming Azure Functions supports .NET Framework and .NET Core, so on and so forth. What version of .NET Core does it currently support, and does it support other programming languages outside of the .NET ecosystem?
Yeah, absolutely. This is actually, unfortunately, a little complicated.
Okay.
But the core idea is Azure Functions supports right now two major versions in production.
Okay.
We have a version 1 and a version 2. Version 1 is where we currently have support for .NET Full Framework, and version 2 is .NET Core. This is, of course, because version 2 runs cross-platform locally and has a lot of, it was a fairly large re-architecture. So using .NET Core has allowed us to do a lot of additional things that we do, like new languages that we've enabled. So I can talk about that in a second as well.
Okay.
But the core idea is V1 is .NET Full Framework. It will be supported for quite a while. Version 2 is .NET Core as well. We do at some point plan on supporting .NET Full Framework in the later versions of functions, but as of right now, that's the split. It's V1 is framework, V2 is core. So with that, right now we support in V2. That's obviously where all of the active development is going. In V2, we support .NET Core 2. We're actually, when .NET Core 3 goes GA, coming in a couple months here, we are going to support .NET Core 3 shortly thereafter. We don't have an official date for that yet, but we have to wait until they have GA, of course, until we take those changes into our host and then make that fully available. Yeah, so that's kind of the .NET picture. Other than that, we have some other languages that you can run in functions. Node, so JavaScript, TypeScript, those are both available in V1 and V2. Of course, on V1, the Node experience was actually pegged at Node 6. And in V2, you can use Node 8 and Node 10 and kind of the other languages going forward. It's actually kind of interesting. In V1, we were using a library called Edge.js that transpiled the JavaScript code to .NET, and all kind of running in the same process, which was a very interesting hack that we had going. Obviously, it wasn't sustainable, which is why we were pegged at that major version. The library wasn't maintained. It had a whole host of issues associated with it. This is one of the reasons that we did our re-architecture to V2 was to enable this kind of out-of-process language model. So we use a library called gRPC to communicate between our host, which is written in .NET, and all of these different language workers, which are written in whatever language that the actual code is running in. So that's how we're able to support the other languages we support, which are Node. We support Java as well. We have in preview right now, we have Python and PowerShell. Yeah, and that's the list right now. There are, always talk of enabling more. And because our model is actually fairly extensible, we've seen a lot of people in the community pick up and build very small proofs of concept of other languages as well. Like I've seen a Go worker floating around. I've seen a Rust worker floating around. There's a pretty big difference between someone building it and getting it to work and us supporting it in production, though. So I can't make any promises, of course, on roadmap or what we'll actually support in production anytime soon. But that's a little bit into our architecture and how that works and how we manage to support many languages.
So you would choose version 1 if you want to use the .NET framework, version 2 if you want to use core. Mm-hmm. But regardless of which one you use, the outside applications, spas or other APIs that are talking to it, it doesn't matter, right? In that case, it's there's no difference between the two.
Yeah, there shouldn't be any difference from the actual outside application talking to it. It's just what your code is looking, what the code itself looks like, right. What the behavior of the host under the cover is. There are some performance optimizations and things as well in version 2. As you can imagine, any major version update of a product will have many different improvements. And actually, when we do, it's interesting. When we do release support for .NET 3, we'll have to update our major version to 3 as well because the code, the .NET Core 3 will change a lot, but it doesn't actually impact. And we're hoping to not have any breaking changes for functions 2 to functions 3. 1 to 2 was a really big jump. Hopefully every subsequent release will be a lot smoother, if that makes sense, just because we've ironed out a lot of the, architecture issues we had with our first product.
So for these other languages, Java and Node, my understanding, and I've tinkered with them some, is that there are extensions for a number of Azure pieces in VS Code. For someone who's writing Node, how would that work? What's the flow there?
Yeah, so it's great that you ask. I would say our recommended development tool for anyone using .NET is Visual Studio, and anyone using any other language is VS Code. And of course, if you like VS Code and you're a .NET user, you can also do that. But yeah, the VS Code flow is fairly simple. There's the extension library built right into VS Code. You go search for the Azure Functions extension, download it. It takes 15 seconds or so. Once you've downloaded that, it'll have to reload the application, and then what it'll do is then you'll get this nice little Azure A on the left pane of VS Code, and it will give you in that extension a really nice tooling on how to get started, kind of very similar to what we get in VS. So it'll give you the option to create a new function app. Within that function app that you've provisioned, it will create new functions. When you're creating the function app, it'll of course ask you what language you'd like to write the functions in, so it kind of knows what templates to use, and it tells you all this information about what's in preview, what's not in preview, all that good stuff. You can have templates for all of the different triggers we support, and then from there, the really cool part about Azure Functions actually that I probably should have already mentioned is that when you're running in VS or running in VS Code, it's actually running the same exact host, the same exact runtime that it's running up in Azure. is what's running locally on your machine. So you're not going to have any like, oh, it works on my machine, but not in production bugs, because at least for the functions runtime part, it's the exact same bits that are running. The only place where you get into issues is like native dependencies. I know this is an issue in Python in particular. People have a lot of dependencies that are built specifically based on whatever machine they're running on, whatever OS image. And so with that, we have things like remote builds that will kind of help with that. The core idea here is that the VS Code experience and the VS experience really try to mimic the Azure experience very closely. And then, of course, we give you the ability to then push that code right up to Azure.
That's awesome.
So when you're testing and things are running locally, that means you're not paying for anything. So really all the testing calls, that's totally free.
Mm-hmm. Exactly. Yeah. Testing's a great point. And we make it really easy with these tools. I mean, it's a real asset that we, it's Microsoft. So we have Visual Studio and VS Code. It's really nice to just be able to run a breakpoint and have that code actually running. And the cool part is that if you're running locally, you can have your connection strings hooked up to whatever actual like Azure resources you want. So I can test on my local machine, like actually dropping a blob in Azure Blob Storage, having that test my functions code, and then put it wherever else it needs to go. I can have that entire thing running locally on my machine exactly as it would in production, except maybe with different connection strings or different machines. And you're right, it's completely free if it's on your machine.
For functions, I'm using extensions, spun up a function app, I'm writing it locally. If I were writing those functions, API calls, would it be similar to doing Web API 2? Would I be able to use Entity Framework Core, right? The kind of the same flow that I would get in a standalone application?
Yeah, so I think what I'm getting out of the question is how can I kind of use functions to connect to a database? Does that sound reasonable?
Yeah, right. You've got several ORMs, mappers, Entity Framework, right, is a really common one. How would you approach that in a function?
Two different ways. One, we do have these bindings. If you want to connect to, say, a SQL Server or something, we do have things out of the box that will let you very easily hook up to whatever database you're using, whether it's mostly a couple of the Azure services like Cosmos DB. And then the second way I would say is that we really, because it's just code and we're running whatever code you have, if you grab the SDK or binary or whatever library you want to actually connect with whatever resource you need, so long as you're properly authenticated with that resource via either the application settings or whatever other way you need to authenticate, whether it's something in Key Vault or managed identity like I'm talking about, or like I was talking about earlier, any of these ways you can actually just, refer to other resources the way you would with any other application. The one interesting thing to note here, though, is that you'll want to manage your connections pretty carefully because of the whole distributed nature of Azure Functions. The basic way to describe this is the host persists statically declared objects between invocations of functions.
Okay.
Whereas if you are instantiating an object within one invocation, that will happen thousands and thousands of times, right? So you can very quickly reach like port exhaustion on the machines that you're actually running on. So that's just kind of one gotcha that a lot of people don't think about, is that when you're dealing with things like connecting to a SQL database or connecting to, even just like I was saying, instantiating HTTP requests, you're going to want to use a factory pattern kind of thing, or like I was saying, a static client rather than actually newing up a new client every single invocation.
So there's no connection pooling going on there?
Not out of the box. Within a single invocation, there's not. I think we'll do connection pooling for you if you declare things properly, I guess, outside of the actual scope of one invocation. But we don't do anything intelligent to figure out within an invocation. We actually need to, because something's being declared every single time in an invocation, we don't pull that out automatically for you, for instance. So that's just a gotcha I thought would.
Okay. That's helpful.
Worth mentioning.
So are functions stateless, or is there a way to have them have state and maybe share information between?
That's a great question. Yeah. So this is actually a really cool thing that functions has that a lot of other cloud providers don't have, and something that we think is a real differentiator that people seem to really like. So we have this thing called durable functions. So durable functions is basically a way to have stateful functions. It's a workflow orchestrator in code. So if any of you are familiar with Logic Apps, that's kind of one of Azure's way of orchestrating things through this visual workflow designer, and it lets you have kind of hundreds of connections to other first-party and third-party applications. But Durable Functions lets you do similar things in the sense that it is an orchestrator, but it is an orchestrator that is exclusively in code. So that's really powerful because that lets you do pretty much anything you want. And I guess orchestration aspect and the persistent state is something that is really different than the rest of functions and something that is really powerful. So an example of when you would use durable functions is something like chaining functions together. I think that's a really easy one to understand is maybe you actually want to circumvent our timeout limits. In the serverless plan, we have limits on the amount of time a single invocation can go. These limits don't exist in other plans, but in the serverless plan, we don't want individual invocations going for too long because we need to allocate and deallocate. So if you want to, say, perform some compute-heavy operation, maybe you're doing some cryptography or something, the easiest way to do that would be you have a durable function, which kind of orchestrates. You've got an orchestrator function and then an activity function. So the orchestrator kind of delegates work to the individual activity functions. They can do whatever operations they would like and then pass that state on to the next function. So that's kind of how the chaining pattern works. But one other way that this will actually benefit users is that we have this really interesting fan out, fan in pattern. You can actually do really interesting things like map reduce with durable functions. But the core idea here is it's fairly easy in serverless to fan out. It's very easy to say, I want this function to, make an HTTP call to these many different places. What's much harder is fanning back in. What's collecting all of those responses back to one function. And so durable functions makes it very easy to do this because you're kind of persisting the state as you go. It actually has this really clever mechanism of building up its state as it goes along. It's built on the durable task framework, which is very, very, very cool tech. That's kind of my brief introduction to durable functions. It's a really nice extension to Azure Functions. And then the one other part that I wanted to mention is that we have a really cool recent addition to durable functions. I think it's Durable Functions 2.0 is what we're calling it. But don't worry, it's not nearly as big as Functions 2.0. It's not that massive breaking change that happened between V1 and V2 for functions. But what Durable 2.0 has is support for what we're calling durable entities. And this is kind of a way of doing the kind of stateful actor pattern in functions. So this is really cool because it lets you do things like have a persistent object that lives through all time. It ensures consistency. It ensures that you can, maybe I'm not describing this the best way, but the actor pattern is such that there's only one instance online at any time. If I increment the value of that actor and then I take 10 different requests at once, I won't get different requests from everywhere. It's kind of a classic distributed systems problem of many different people requesting for the same value at the same time, making different increment, decrement on this actor.
So it's a singleton?
It's a singleton. There you go. That's exactly the word I was missing. Yeah, no, it's a singleton. It's a stateful singleton. It works really well. It's very, very new. It was actually, we had a team hackathon a little while ago, and it was I saw a really cool demo of this. Not that it was a hackathon project. Someone just made a cool tweak on it that we thought was pretty interesting. But it's a really cool piece of tech. Durable functions is something that we overall think is a really, really cool piece that people seem to get very excited about.
I have a question outside of enterprise or companies. How would someone, say like me, who's hosting their own website that shows their skills and kind of their resume?
Sure.
My understanding is that you can actually use Azure Storage for static sites like Angular, right? And then have that static site talk to Azure Functions. Say, for instance, if someone wants to send me an email and I've got that functionality in a function, make the call, process it, send it out, and then the function will spin back down. Is that reasonable? And
Absolutely.
I'm assuming the cost would be fairly low in that case.
Definitely. This is actually a pattern we're seeing more and more, this kind of web API workload with someone using a static website. The very easiest way to build a website is a static website. There was this big movement a while back about, building static websites. It kind of ultimately didn't go that far because you really do eventually need some sort of server-side logic. You do need some secret. You do need something that the user can't know about, essentially. And kind of the advent of serverless has kind of made this this promise of static site's actually a reality, because you don't have to stand up a full I don't know, Express backend for a Node app, or whatever other framework, Flask for Python, whatever you want to do. Even those very simple frameworks for creating web APIs, you don't have to stand up a full application for your server side. You can just have your static application with maybe one or two calls to a function that will handle your server side logic. So storage makes this easy. We have it's the $web, I think is the actual place you go find it. But the idea is you can host your static website on Azure Storage, and then it's fairly easy to then stand up a simple Azure function that will then handle API calls to that function. So you make a call from your front end to the endpoint that you know is your Azure function. It's, again, as you were saying, very cheap, because for functions you're only paying for what you use, and for static storage it's just hosting the static content. There's no compute there. It's just hosting static content. It's not that expensive.
It's not an app service.
Yeah. No, it's certainly not app service.
Right.
So yeah, this is definitely a way we're seeing people building applications lately. It's a pattern that we like a lot, particularly, I'm on the Azure Functions team, so we like quite a few people. We're seeing quite a few people using functions as these slim web API backends for a static website.
And I think you have some tutorials on for using VS Code functions and static websites. We'll put them in the show notes. But yeah, no, that's awesome. That's cool.
Yeah. So is there anything that people shouldn't do with Azure Functions?
Is there anything that people shouldn't do? Yes. So I would say that I did point earlier to, I don't think it's a good idea to just take your existing application and then plop it in a function. We've seen people doing that and kind of trying to flex the boundaries of our system. I don't really advise doing that. If you're going to move to functions, it's better to do it with something that's new, something that's a small piece that's extending an existing application, or via a re-architecture where you're kind of breaking up your app into its small components. Another thing I want to say is that actually does kind of get into one of the probably biggest anti-pattern we see is just every function should have one purpose. It's a small thing. It's the equivalent of a method in any other programming paradigm. It should do one thing, and if your function's anywhere over, I don't know, just to put an artificial limit, say 100 lines of code, you're probably doing too much inside the function. So that's where you could use something like durable functions to maybe chain the results between each other, or have many different functions that have different purposes. Other than that, I would say if you want the serverless scale, it's tough to have functions that are doing really compute-heavy workloads. I would say functions is much better for I/O-bound workloads, things that are about processing events, what functions is actually made for. Doing, say, I don't know, to take Python for an example, I would think the inference step of machine learning is much, much more applicable to functions than the training step of machine learning. So anything that's really like high performance computing or really CPU intensive is something that's probably better elsewhere.
Okay.
Yeah, I think many, many small events rather than one very big event.
That makes sense.
Yeah.
So is there anything else you want to cover before we get to picks?
No, I think we're good. I think we got to everything.
Cool.
You want to go first, Caleb?
Yeah. So my pick this week is actually Elder Scrolls Online. With the limited time I've had lately, I've actually gotten back into it with the Elsewhere update, and I'm leveling a tank. So go MMOs.
Cool. My pick this week is another podcast. It's NPR's Planet Money. I like listening to it because, I like economics and things like that. And they put some pretty interesting shows out there that talk about oil pipelines. They've talked about launching mini satellites. They talked about the chicken tax, which is something interesting about how the chickens and taxes and relates to imported pickup trucks. So my pick is NPR's Planet Money. And what do you got for us, Colby?
Yeah, I think that my recommendation, my pick, is a show I've been watching on Netflix recently, Dark. It is a German TV show that is dubbed, which is new for me. I don't usually watch dubbed shows, but it's really good. I don't think I'm giving too much away to say that it's about time travel. And I find it fascinating, and it's kind of a really interesting. It is. I mean, the show name is not inaccurate. It's kind of a dark, interesting mystery kind of mystery thriller, if that makes sense. Very, very interesting show. It's definitely something to check out. And I find that at first the dubbing bothered me. The fact that it wasn't, the mouths didn't match up with the words they were saying.
Right.
But I find that if I'm not actually watching perfectly, if I'm like doing something else while I'm watching, it's perfect because I can just listen to it and then I sort of see what's happening, but I don't actually get hung up on the minor details that of course will bother me. But yeah, so Dark, that's my recommendation.
Good deal.
Very cool. I'll have to check that out.
Yeah, the reason I recommended it too is that season 2 just came out. That was the part I missed.
Okay.
So if anybody wants to reach out to you and has questions, is there a way they can do that?
Yeah, absolutely. So we kind of the entire Azure Functions team is super available on social media. So first of all, we have a pretty big Twitter presence. We have the Azure Functions Twitter handle. My Twitter handle is just @Colby Tresness, my full name. Also, if you have any questions, comments, or concerns about Azure Functions in general, we're completely open source. So at least the functions host part, the part that actually runs your functions. Yeah, the reason I make the distinction is some of the Azure infrastructure, of course, is not open source, but the actual Azure Functions part is. And we have again a lot of presence on GitHub. You can see all of our developers, figure out what we're doing if you're curious. And then the meta repo, the one to go to start with, is just Azure-Functions. It's Azure-Functions.
Cool.
Yeah.
I just want to let listeners know if they want to reach out to any of the hosts of the shows, not just this one, but any of the devchat.tv podcasts, they can go to devchat.tv, and at the top they can click on chat, and that'll take them to a Discord group where they can reach out with other people that are watching or listening to the shows and any of the hosts. So thanks for coming and talking to us about Azure Functions, Colby. Appreciate it.
Absolutely. Thanks for having me.
Thank you.
It's been good. Thank you.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CacheFly.com to learn more.